At the Fort Collins Museum of Discovery, you can see the principle of the lever at work in a wonderful interactive display using a lever to lift a piano. As you move farther and farther from the pivot, less and less force is needed. But the most interesting place to look for levers at work is in the history part of the museum, in the skeletons. In this skeleton of an ancient bison, you can see where muscles attach to bones and where the bones pivot. If the muscles attach far from the pivot, you get more leverage. So muscles cause the rear feet to provide powerful forces. In the spine, long extensions lead to the large forces needed to lift a heavy head, to raise it in a fight, or to push through the snow. It's traditional to close an episode of Everyday Science by having food of some kind. And today we said, what could we make that uses wedges and levers? And we came up with the idea of root beer floats. And if we, who doesn't love that? Who doesn't love that? So if we start with a bottle of root beer, and I'm going to have to pull the cap off, I've got an opener. And tell me, what principle is at work here if I open
Leverage.
Leverage.
So, leverage.
Oh, yeah. Oh, yeah. That's it. Because I've got a little tiny distance. There's a little pivot right here. And I've got a little tiny distance right there. And I apply my force out here at a big distance. And so what that means is, go ahead and give that a shot.
Okay,
You take
so
that?
right here.
Uh-huh. So you're going to take that and push this on. And you're applying a force way out at a great distance. Oh, yes. And there we go. There we go. Excellent. Excellent. Oh, you know, I just realized, too, we have pipes. We could, like, make the totally enhanced, like, bottle opener.
Oh, that'd be so.
Yeah.
Wow.
Holy cow.
Like,
There we go.
super big.
So now,
Holy cow.
your turn. I'm going to go ahead and hold the bottle. We'll put this here. Now, you're at a really, really huge distance. And so my theory is that you should be able to open this pretty easily. Go ahead and pull up on it. Oh, yeah. Oh, yeah.
Wow.
There we go. And that was the principle. That was the principle of the lever. How about the principle of the wedge? How does the wedge apply? How does the wedge apply?
Oh, the little hook right here where it goes underneath
Oh.
the edge, it's pushing
Pushing in?
into it.
I like it. I like it. But you know another place it applies?
Ice cream scoop.
Yes, because the ice cream scoop. Go ahead and take a look at this and look at how it's shaped.
Mm-hmm.
Thin
It's thin on the edge,
and
And thicker.
thicker on in the middle.
so if you force that into the ice cream,
It's gonna scoop it out.
oh yeah. And since you were talking about wedges earlier, I think you're going to use a wedge to serve us up some ice cream. And when you make a root beer float, you tell me, do you do the ice cream first or do you do the root beer float
You do the ice cream first.
Always ice
Always.
cream first.
Okay,
Always.
well, you folks have opinions about this. I didn't have a strong opinion, so we will let you. Oh, sorry, get some ice on you.
You get
So there we go. Let's wedge us out some ice cream. And we've got one more bottle of root beer to open, so we each get one. And I'll let you use a lever. So you're
Okay.
working the lever, you're working the wedge. Oh, yeah, that's looking good, actually. Here we go. And we've got Little Shop of Physics glasses.
Ooh, that
Oh,
was
yeah.
almost bad.
Well done, well done. And we're doing ice cream first.
Mm-hmm.
Excellent.
Always ice cream first.
Always been ice cream first.
Is that right?
I don't know. We've always done
Traditional in
ice
my
cream
family.
first.
Yeah,
no.
that's
So-
kind of
Is
traditional
it tradition?
for us.
So we have raw materials for root beer float for you, for McKenzie, and for Taylor,
Ooh.
and one for me. And so we go ahead and pour, and I think we're going to get some fizzing. And there's some physics going on there too, of course. There's a little carbon dioxide dissolved in liquid kind of thing happening. Oh yeah, oh yeah. And then you're going to drink the root beer floats with the straws, but then we're also going to use ice cream. And to get the ice cream out, we've got spoons. And you folks, oh yeah, made special spoons. And the idea with these is, if I have to lever something with this one, oh yeah, it's going down. It looks like yours is all about the twist. Yours is all about the twist. And so you can apply huge twisting forces to this. If I try to go up against that spoon, I'm gonna lose. And yours is all about the lever. Oh yeah. Oh yeah. And actually, that
shovel.
would be great for leveraging ice cream out of the container. Oh yeah. It does not stand a chance. Excellent. So I'm going to give myself a little bit more ice cream in mine. You want to grab a little bit more ice cream with your torque-enhanced spoon?
Sure, let's see how well this
See
one
how
goes.
this works.
Oh, yeah. You can twist, too. You got it. The ice cream does not stand a chance.
Yeah.
All right.
All right.
Mackenzie, your
See
turn.
how this works.
Oh, yeah, and then lever that out. Oh, my gosh. You're,
Oh,
you're
wow.
bending the spoon. You're bending.
Wow.
Spoon
look at
bendage.
that.
Oh, yeah, there we go. And then we'll toast the conclusion of another successful episode of Everyday Science. Taylor,
Woo.
Mackenzie. Oh, yeah.
We'll see you next time at Everyday Science.